Hey, hello everyone. Welcome back to our channel Physics, where we actually learn physics. So in this lecture, we are gonna see various units of measurement of length. Okay, we are gonna see various units of measurement of length. Okay, that means what are the different types of units that we actually use for the measurement of length. Okay, so let's see what are those units. We will try to define some of the important types of units that we actually use. Okay, so if I start with the first and most basic type of unit for length is meter, isn't it? This is something that we generally use actually. We use meters for the measurement of various length, isn't it? So the first unit that I can say is meter. Okay, and we already know it, and I think we have defined that in some other video also. In this video we are not going to talk about this meter. We are going to talk about some special types of units actually that are used, especially the very large units of measurement of length. Okay, very large ones, especially the astronomical ones. Okay, so that is the main purpose of this lecture. Okay, meter is something that we know. See, again in meter we have lots of prefixes, like we have centimeter, we have mm, that is millimeter, we have something like micrometer. Okay, we also have something like nanometer. Okay, we have Armstrong unit, that is nothing but 10 raised to minus 10 meters. Okay, we have something like femtometer. Okay, 10 raised to minus 15, and many other actually, but I'm just talking about few of the important ones. Okay, so this is something that we generally use. Yeah, if I talk about the bigger one, there is one more, that is kilometers. Okay, that is generally we use actually. So these are some prefixes for meter. Okay, so we are not going to talk much about this. I will straightly move to the most important topic here, and that is the large units of measurement of length. Okay, so let's see what are those units of measurement. Okay, so over here, if I be precise, there are actually three such. Okay, there are actually three such units. The first one that comes into our mind is the astronomical unit. Okay, astronomical unit. It is denoted by AU. So this is one of the units that is used for the measurement of very large distances. See, just like we have meter, we have AU. Okay, just like we have meter, like we say the distance is 20 meters. Same way, the larger distances are measured in astronomical units. We say the distance between something like this star and that star is 20 astronomical units, something like that. Okay, so this is also a unit. So what is it actually? How do we define this astronomical unit? Isn't it? That is a question. How? So it's very simple. See, this is sun, you know, isn't it? Sun is at the center of the solar system. Okay, our solar system. Let's say this is earth somewhere here. Okay, let's say this is earth, and as we know that earth revolves, isn't it? Earth revolves around this sun. Okay, earth revolves around the sun, okay, in an elliptical orbit that we all know. Okay, so this average distance or this mean distance, okay, the mean distance between the sun and the earth, the mean distance between the sun and the earth is called as the astronomical unit. Okay, it is called as the astronomical unit. What is it? The mean distance between the sun and the earth, okay, is called as the astronomical unit. Yes, there is a certain value to this. Okay, one astronomical unit is actually equal to 1.5 1.496 into 10 raised to 11 meters. Okay, if I be precise, then this is about 1.496 into 10 raised to 11 meters. Okay, so this is the value for one astronomical unit. Okay, so now you get this idea. You can see how big that number is, 10 raised to 11. Okay, so this big is the number. Okay, so this is one of the units used for large distances. Okay, so just keep that in mind. Okay, now we move to the second one. Okay, second one is the light year. The light year. Okay, we denote this by Ly. Okay, the light year, Ly. Okay, so let's see what is it. Again, this is a unit of length. Okay, that means just like we measure 20 meters, we can say 20 light years, but it's a very large actually. Okay, so first of all, let's try to define this. Okay, let's try to explain what is light years. Okay, over here, as we all know, the speed of light is how much? It is about 3 into 10 raised to 8 meters per second. Okay, this is not actual. The actual number would be 2.9979 2458 into 10 raised to 8 meter per second. How much? 2.9979 2458 into 10 raised to 8 meter per second. That is the exact number, but 3 is a rounded off number. No problems with that. Okay, so now this is the speed. Now what do you mean by speed? Speed is equal to distance upon time. Okay, distance upon time. Okay, now from this I can write distance is equal to c into t, that is speed of light into some time. Okay, now I can calculate what distance light can travel in some time t. Okay, see, I can give you some number, okay, in the place of this t. Let's say in 20 minutes. Okay, in 20 minutes, how much distance does this light travel with this much speed? You can calculate from this equation, isn't it? Just put the number, this number c, and put the time in seconds. 20 minutes, convert that to seconds, and you will get the distance traveled by light. Okay, you can put any number here that you want. Okay, let's say how much distance light travels in 1 month, 2 months. Okay, like that. So in a similar way, light also travels, okay, some distance in 1 year, isn't it? It must be traveling certain distance in 1 year. Okay, the distance that light travels, okay, the distance that light travels in exactly 1 year, okay, in exactly 1 year is called as 1 light year. Okay, the distance that light travels in exactly 1 year is called as 1 light year. Okay, so this is how we define 1 light year. Okay, we can calculate how much is it. See here, we have got the time. What is time? It is 1 year, isn't it? But we cannot use this. We have to use second. Okay, we have to convert this to seconds. So we can easily convert that. This is 365 days. Okay, each day consists of 24 hours. Each hour consists of 60 minutes. Each minute consists of 60 seconds. So this is the time in second. Okay, this is in seconds, and we can now put all these numbers. See, we know c, we know this t. We can just put this and we can calculate what is the distance that light travels, okay, in 1 year. See, I have put the value of c first into now this t is what, this 365 into 24 into 60 into 60. Okay, now that's pretty easy. Now we can calculate this. So here I have this calculator with me. Okay, I can calculate this. This is 3 into 10 raised to 8, 9.46 into 10 raised to 15 meters. You can see how big this number is. Okay, over there we saw the value of 1 astronomical unit. It is about 10 raised to 11. Okay, here we can see it is much bigger than this. Okay, you can see here 10 raised to 11, this is 10 raised to 50. In fact, look at this number, this is 9.46, this is almost 10. So if we consider this as 10, then this 10 into 10 raised to 15 will be 10 raised to 16. So that means the distance traveled by light in 1 year in vacuum, okay, is about 10 raised to 16 meters. Okay, it is about 10 raised to 16 meters. Okay, so you can imagine how big that number is. Okay, so that's why this is the unit that we use in astronomical scales. Okay, because over there the distances are very large generally. Okay, like the distances between the star. Okay, that is very big, generally in light years. Okay, so that's why we use it. So this is light year, another unit. Now we move to the other one. After astronomical unit, after light year, we move to the next one, and that is called as the parsec. Okay, the third one is the parsec. Okay, so let's see what is this parsec. From this name itself, you can see there is some link. Okay, you can see here par and this is sec. That means it is related to something like parallax, and this is second. Parallax is phenomenon that we have seen. Second is a unit of measurement of angle, small angles, isn't it? Okay, so there is some relation between parallax and this small angle unit, that is second. Okay, so let's see how exactly it is. Okay, so we have already seen what parallax is in the previous videos. Okay, if you have not seen that, just go and check what is parallax and then you can come back. Okay, so I will be talking about this parallax over here. See, suppose this is some distance. Okay, this is some distance, let's say L. Okay, this is some distance L. Okay, now let's say here is some point, and this point, let's say this point is O, and this point subtends certain angle. Okay, theta. Okay, this point subtends certain angle theta. Okay, now if you have seen the video about parallax, you will see that this angle, in case of parallax, this angle is called as a parallax angle. This distance is called as the basis. Okay, this distance is called as basis. Okay, so the angle that basis subtends, okay, at a certain point is called as parallax angle. This is a basis. Okay, now this distance can be anything, this angle can be anything. Okay, now imagine that this angle is 1 second. Okay, this angle is 1 second, and this length is 1 astronomical unit. You know what 1 astronomical unit is over there, over here. This is 1 astronomical unit. Okay, this is sun, this is earth. The distance between them is 1 astronomical unit. Okay, let's say that this is 1 astronomical unit and this is 1 second. Okay, if these conditions are satisfied, okay, if these conditions are satisfied, then these distances, okay, then these distances are called as parsec. This is called as the parsec. Okay, if this parallax angle is 1 second and this length of a basis is 1 astronomical unit, then this distance is called as what? The parsec. Okay, this is called as a parsec. Okay, now we can define this. Now if you look at this carefully, 1 astronomical unit is something that you will only see here. Okay, so this is taken as a reference. Okay, generally this parsec is used for the measurement of distances to the stars from our galaxy, okay, or from our solar system at least. Okay, so I will use that as a reference. Let's say this is the sun, okay, over here this is the earth, okay, this is sun, this is earth, this is 1 astronomical unit over here. Okay, now here is some star, okay, let's say here is some star, and over here we can see it is subtending certain angle, okay, over here, and let's say this angle is exactly 1 second. Now in that case this distance is exactly equal to 1 parsec, okay, 1 pc, that is 1 parsec. This distance is exactly 1 parsec. See, this distance is very big, so this distance would also be almost the same, that is 1 parsec. Okay, so now we can define, okay, we can define what this parsec is from this given situation. Okay, okay, now see here, 1 parsec is a distance, okay, 1 parsec is a distance from where, okay, you can see here 1 parsec is a distance from where 1 astronomical unit, okay, 1 astronomical unit subtends an angle of 1 second exactly. Okay, 1 parsec is a distance from which 1 astronomical unit subtends an angle of 1 second. You can see here this is a distance, and from this distance this 1 astronomical units subtends an angle of 1 second only. Okay, so this is how much? 1 parsec. Okay, there is certain value to this actually. 1 parsec, when we calculate, it is about 3.08 into 10 raised to 16 meter. Okay, this is how much? 1 parsec is equal to 3.08 into 10 raised to 16 meters, and this is nearly equal to about 3.26 light years. So in this way we have defined 3 different units for distances. Okay, so first one was this, that we already know. We are not talking about this, we are talking about the large one, that is the astronomical unit over here first of all. And what was the value? This much, okay, that we can see over there. What is 1 astronomical unit? It is the distance or the average distance between earth and the sun. Okay, then we talked about the light year. Light year is what? It is the distance traveled by light, okay, in exactly 1 year. Exactly 1 year, that is 1 light year. Next one was this parsec, which is related to that parallax and second. Okay, so here is a simple way of defining it. Okay, this is a distance, how much? 1 astronomical unit, that is sun and the earth. Okay, so there is certain star, for example. Okay, so the distance between the sun and the star would be taken as 1 parsec if this 1 astronomical unit subtends an angle of 1 second with this star or this point. Okay, or in another way we can say here 1 parsec is a distance from which, or from where, 1 parsec is a distance from where 1 astronomical unit subtends an angle of 1 second. Okay, so that is how we define 1 parsec. Okay, so these are some units of measurement of length. Okay, I hope this is clear to everyone. Okay, I hope you understood what is parsec, what is light year, what is astronomical unit. In most cases, this one is mostly used actually. This is very famous. Okay, parsec is also used, but I would say this one you will find out a lot in books. Okay, more than these two. Okay, this is a constant actually, one astronomical unit. Okay, this is again a constant. I mean, everyone is a constant, but this is something that you can observe actually. I mean, this is sun and earth, the distance between them. Okay, so I hope this is clear to each and everyone. If not, you can just tell me. Okay, so this is it for right now. I will see you in the next video. Okay, till then, bye bye, see you, have a nice day.